Bismillahirrahmanirrahim. So student, today the topic which we will discuss is find the sum of infinite geometric sequence. Okay student, in this topic we will discuss about the infinite geometric sequence. In previous topic we discussed about finding sum of n terms of geometric sequence. In previous topic we have to just find Sn, where n is for the number of terms, that is that sequence was finite, so we will use this formula. Okay student, but now we have to find sum, but what we have to find? Sum of infinite geometric sequence. Okay student, so we will find the sum, but here we will be use infinity because we are talking about infinite geometric sequence. So here we have to find S infinity. Now what is infinite geometric sequence? Student, whenever any sequence is given that is geometric sequence, as I write here its general form, here a sequence is given. As you can see, the first term is a1, second term is a1r, third term is ar square, and similarly goes on, and it goes infinitely, that is it has no last term. Okay student, when there is a sequence and there is no last term of that sequence, then we will say that this sequence is infinite sequence. Okay student, so for finding sum of infinite geometric sequence, its formula will be different. Okay, but process will be same, as we will first step for finding sum of infinite geometric sequence. First of all, we will find the value of r, and we will check if it is greater than 1 or less than 1 as we do in the previous video for finding sum of n terms of geometric sequence. Similarly, we do the same process here. So first of all, what we will do, we will find the value of ratio, and as you know, ratio, for finding ratio we use formula a2 divided by a1. So if we get ratio answer which is greater than 1, then you will write the statement. You will write that S infinity is not possible. Okay, you have to just write this statement, and there is no need to solve the whole answer. Okay student, in case when ratio answer is greater than 1 means answer is 2, 3, 4, 5 up to goes on. Okay, but if it will be the case 1, but if we get the ratio answer which is less than 1, now less than 1 means the numbers which are less than 1 are 0, 0.5, 0.001 and all the negative numbers. So if we get the ratio answer which is less than 1, then we will use the formula which will use to find the sum of infinite geometric sequence. And the formula which we will use for finding sum of infinite geometric sequence is S infinity is equal to a1 divided by 1 minus r. Okay student, when where a1 is first term of the sequence and r is the ratio, and you know how we will find the ratio, as we have the formula a2 divided by a1. Okay student, so you have to just remember this formula, and you have to just put the values in this formula, and your question will be solved. Now I will go further and I will solve example for you, so the process become clear to you. So I have the example number 1. Find sum of infinite geometric progression 6, 12, 9 up to so on. So in this example, what we have to find? Student, in this example, as you can see, we have to find the sum of infinite geometric progression, which means we have to find S but infinity. So we have to find S infinity. Okay, and sequence is given which is infinite geometric sequence or progression. Now I will start the solution. First of all, what is given to us, I will write that thing. Given sequence is 6, 12, 9 up to infinity. So here the sequence is given and we have to find the S infinity, that is sum of infinite geometric progression. So to find infinite geometric progression, you know that we use formula which is equal to S infinity is equal to A1 divided by 1 minus R. But first of all, to use this formula, we have to just find the value of R. So we will know that we are able to use this formula or not. Okay. So first of all, we will find the value of R. As you know that R is equal to A2 divided by A1. So from given sequence, you can see that A2 is 12 and A1 is 6. So I will write both values and they will cancel out each other and I will get 2. So here R is equal to I think I had made a little mistake here. Okay student, I will go for this, as R is equal to 2 which is greater than 1. Student, as we get the answer which is greater than 1, so it means finding S infinity is not possible, because we get the answer which is greater than 1. So we are not able to find the sum of infinite geometric progression. Okay student, so your answer will be complete at this point. Okay, now I will solve example number 2. As in example number 2, what is given? It is given find sum of infinite geometric progression. Here 16, 12, 9 up to so on. Okay, so here the sequence which is given to us is 16, 12, 9. So I will start my answer. As given sequences 16, 12, 9 up to so on. And what I have to find here, I have to find sum of infinite geometric progression, that is S infinity. I have to find S infinity. So for finding S infinity, first of all I will check the value of R, which is the ratio of the sequence. So for finding R, I will use the formula A2 divided by 1 A1. So here A2 is 12. Okay, and what is A1? A1 is 16. So here I get the answer which is 3 by 4. R is equal to 3 by 4. Now I have to just divide it on calculator and I get the answer in points which is 0.7. So student, as you can see 0.7 is less than 1. Okay, because as you can see it's a 0 value and you know that 0 is less than 1. So it means now I am able to use the formula of S infinity, which was A1 1 minus R. I am now able to find the sum of infinite geometric progression with the help of this formula, because my condition of finding value of R which is less than 1 is satisfied. So it means that now I am able to find this the sum of infinite geometric sequence with the help of this formula. Okay student, now I will go further and I will just put all the values in this formula. So here A1 is given. So what is A1? A1 is the first term of the sequence. So first term is 16. So I will put S infinity is equal to 16 divided by 1 minus what is R? As R is equal to 3 by 4. Okay student, I just don't use the value in decimal, because if I will put this value, then the solution will become difficult. So to keep solution simple, I will use the simple value of r. Okay, now here I get 16, and here in denominator I will take LCM, and I just get 16 divided by 1 by 4. So just shift 4 upward, and here the values will flip, and I get 16 4 is a 64. So student, that is the sum of infinite geometric progression, given geometric progression. Okay, so I just find the value and your answer is just completed. Okay, now I will go for the other topic, which is related to the infinite geometric progression. That is, the name of the topic is recurring decimals. So students, I hope you know about the decimal numbers. What are the decimal numbers? Decimal numbers are all the numbers which has a point between the numbers. Okay, whenever point is involved, you have to just understand that it is a decimal number. These all are decimals numbers. Okay student. And what is fraction number, student? Fraction number is the number which is always in the divide form. For example, here 3 by 4, 2 by 3, 5 by 7. These all are the fraction numbers, and they are in their simplest form, because further cutting of these numbers are not possible. Okay student. So know the difference between the decimal numbers and fraction numbers. I hope the difference between both numbers are clear to you, that what are the fraction numbers and what are the decimal numbers. Now our topic is recurring decimals. So what are recurring decimals, student? As from decimal, one point is clear, that the number has a point in it. Okay, so what is recurring? So I will write here recurring decimals. So student, just remember, recurring is the word used for repeating. Okay, so whenever there is repetition, we will repetition in decimal numbers, we will say that they are recurring decimals. Now what are the numbers which are recurring decimals? For example, here I write, as you can see, this is the decimal number, but what you have see here, student, minute. So student, here you can see that this number is a decimal number, but it is recurring decimal. Recurring, why recurring? Because after point value, as you can see, there is a repetition between repetition in the number, and it goes on, it is infinite. Okay student, so these type of decimals are called the recurring decimals. Okay, and how we can write it in a short form, as it is very difficult to solve your question answers, and you just repeat the same number which is that long in repetition. So we will just write this number in a short form, and the short form is this. As you can see, the which number appears in repetition? 21, 21, 21, 21. So what you will do? You will write 21 one time, and you just put bar on that number. Okay, so when you will just put bar on that number, you will just know that this number is in repetition infinitely. So student, why I am talking about recurring decimals? Because student, all recurring decimals are infinite geometric sequence. Always remember, all recurring decimals are infinite geometric sequence. I will write it here for you, so that it's a point which can be used in objectives too. Okay, so just remember, all recurring decimals are infinite geometric sequence or series. Okay, so whenever this type of recurring decimal occurs, you just have to know that they are talking about infinite geometric series, and you can solve these decimals with the help of rules of infinite geometric series. Okay student, now I will go further and I will solve example for you, so we just know how we will solve these types of questions. So example is, convert 0.21 bar to a common fraction. So student, here it is given that just convert this recurring decimal to a common fraction. So what is common fraction? Fraction, as I just told you above, that fractions are the number which are in their simplest form, and we can write it in a divide form. So we have to just convert this decimal into fraction number. So for this process I will use the formula which I used in previous example, and the formula was sum of infinite geometric sequence, and with the help of this formula I will convert this decimal into a common fraction. So student, I will write the answer here, and I will write the statement for you so it become clear to you that what I am talking about. For converting, wait, okay, for converting recurring decimals into common fractions, we will make infinite geometric sequence and then solve it with the help of sum of infinite geometric progression formula. Okay student, so in this solution we will just follow these steps. So first we will do first what we will do, we will make first of all we will make the sequence from this recurring decimal, and after making sequence we will use the formula which was as in finding sum of infinite geometric progression, that is S infinity. So I will start my solution from here. Solution is what is given to us, this fraction value this recurring decimal is given to us 0.21. okay, and we have, but they asked to us that convert this into common fraction. Okay student, so student, here 0.21 decimal is given and we have to convert it into a common fraction, and for this our first step will be that we will convert this recurring decimal into infinite geometric sequence, and then we will use infinite geometric formula to solve. So here first step will be convert recurring decimal in infinite infinite geometric sequence or progression. So here 0.21 bar. So how I will write it? 0. As bar shows that 21 comes in repetition. So I will write 21, 21, 21 up to so on. Okay. Now after that I will make the sequence. So how I will make the sequence for this? Okay. So for this you have to take the first term of the sequence as it is, which is given. Okay. So here 0.21 is given. So 0.21 will be the first term of the sequence. Okay student. Now for second term you have to just write the same term 0.21, but after decimal you will put number of zeros according to the bar. You have to just see that bar appears on how many numbers. As you can see, bar appears on 1, 2 numbers. So after decimal I will increase to 0. Okay. Similarly for third term, my term will be same 0, 0 to 1, but again I will increase 2 zeros. Okay students, and plus similarly goes on. So student, how many zeros you will just add after decimal? It will depend on the bar that you will observe. That bar appears on how many numbers. Okay, and then according to that you will just put the number of 0 and you have to just increase it in all the terms. Okay student, so I hope you just learn that how you will make the sequence from the recurring decimal. So that is the thing that you will be used to make a sequence. Okay, now what I will do, as I have made the sequence, now I will just find the value of r, because I have to put the formula which was sum of infinite geometric sequence. So for that formula, my first step always is I have to find value of r. So here, as you know, r is equal to a2 by a1. So here second term is 0.0021 divided by first term is 0.21. Okay student, now I have to just solve it on calculator and I get the answer, which is 0.01. Now student, as you can see, 0.01 is less than 1. So you can able to use the sum of infinite geometric sum formula. Okay, if value of r was greater than 1, then you was not able to solve the question with the help of sum of infinite geometric sequence formula. So as r value is less than 1, so we will use formula, and the formula is s infinity a1 1 minus r. Okay student, now what is the value of a1? As from the given sequence you can see the first term of the sequence is, here you can see it's 0.21. So here a1 is equal to 0.21, and what is r? As I find r here, which was 0.01. So I have to just put all values in this formula. So I get 0.21 divided by 1 minus 0.01. Now you have to just solve it on calculator. 0.21 1 minus 0.01 is equal to 0.99. Now student, as I need my answer in fraction form, because in question it is given that question was here convert 0.21 to a common fraction. We have to convert this repeating decimal into a common fraction, that was a by b form. So what I will do here, as my answer is in decimal form, so I will convert it into a fraction form. So I have to just remove this decimal from these numbers. So how I will remove it? As 0.21, you have to just remove the decimal and what appears in denominator 1, and how many numbers you have to count the numbers after decimal, as there are two numbers, so 0 will appear in the decimal. Similarly, for next 0.99, which is in denominator, as I have to remove this decimal, so when I will remove decimal, 1 appears, and how many 0 I will put, as there are two numbers after decimal, so 2 zeros will appear. As you can see here, 100 and 100 will cancel out each other, and I get 21 by 99. So they both will cancel out each other, and I get 7 by 33. So student, as you can see, this is the answer in the fraction form, and the fraction form was we write the answer in divide form, and they are simple numbers and there is no decimal involved in it. Okay student, so this is our final answer. Now I will solve example number 2 for you. Example number 2 is 2.15 bar convert 2.15 bar to a common fraction. So student, what we will do here, as a question, in question it is given that convert this recurring decimal to a common fraction, that is a by b form. So process is the same as we discussed before, but there is a little difference. As you can see, there is a number before decimal. So what we will do here, as we require 0 at this position, but here 2 is given, which is a number. So first of all we will split this number, so we will get 0 here, because if there will be 0 here, then we will be able to make our infinite geometric sequence. If there is no 0 here, then we will not be able to make our geometric sequence. Okay, so as our first step is to make the geometric sequence, but before geometric sequence we need 0 before decimal, so we will just split this decimal, split 2.15. okay, so how I will split it, as 2.15 is equal to 2 plus 0.15. okay student, so that is how you have to just split this number. Now as you can see here 0 comes, so now we are able to make our geometric sequence. So what I will do here, 2 will remain outside and I will make a sequence here. So first term will be this whole term, you have to take this whole term as a first term. The second term will be, okay student, one more thing I want to before this step there is one more step. As there is a bar on two numbers 1 5, so first of all I have to just open the bar, and after that I will make the sequence. okay, so here 2 plus as the first term will be 0.15, so first term will be 0.15 and the second term will be the same, but how many 0 appears after point, as you can see there the bar is on two numbers, so I will add 2 zeros after decimal. Similarly for third term the same number will be there, but again I will add 2 zeros before after the decimal, and similarly goes on. So it's enough, you have to just make the term up to 3 terms. okay, now after that as I make sequence I will just solve this sequence with the help of sum of infinite geometric sequence formula. So for this first of all I will just check the value of r, that if it is greater than 1 or less than 1, If it is greater than 1, then I will not go further and my solution will be complete. But if it will be less than 1, then I will use the formula and then I will go further to solve this answer. So first of all, I have to find value of ratio, as A2 is R is equal to A2 divided by 1. So here A2 is 0.0015 and A1 is 0.15. So here I get, when I just divide it on calculator, I get the answer, and my answer is 0.01, which is again less than 1. So it means now I am able to find the sum of infinite geometric sequence with the help of formula, which is S infinity is equal to A1 divided by 1 minus R. Now what is A1? A1 is the first term of the sequence. So in this sequence the first term is 0.15. So I will write its value here, 0.15. 1 minus what is R, as I find R here. So R is equal to 0.01. So I have to just do these calculations on the calculator, and here I get 1 minus 0.01 is equal to 0.99. So again student, as you can see that my answer is in decimal form, but I require my answer in fraction form. So I have to just put this value here. As you can see, the 2 is also with this sequence. So I will write this 2 here, 2 plus, and I will write this answer which comes from the formula here. Okay student, and now I will go further and I will solve it again. So here what I will do, 2 plus, I have to convert this decimal into fractions. So for this I have to just remove these fractions. So how I will these points, decimals. So how I will remove the point value, I have to just remove this. 1 appears, and how many zeros I will add? 2, and in 0.99 again I have to remove this decimal. 1 appears, and how many zeros? 2, because after decimal there are 2 numbers. Okay student, now 100 and 100 will cancel out each other, and here I get 2 plus 15 divided by 99. Here I have to just take the LCM, and I just get 198 plus 15, which is equal to 213 by 99. So student, I have just convert my decimal, which was 2.15, into 213 by 99, which is the fraction form. Okay student, so my answer is complete. So student, I hope the topic is clear to you. So let's go further and I will solve one more example for you, but I think it's enough and the topic is complete today. So we will meet in the next video. Okay students, thank you so much.